Hi everyone, Mrs. Enders again to finish up the topic 6.2 presentation. This is the second part, and we're starting with the slide that we ended with, which is the starting to talk about the ODSs, or ozone depleting substances. As I mentioned before, these are all man-made chemicals, substances, and they are pollution. As you can see from the table, except for the nitrogen oxides, the CFCs and the HFCs, etc., they release halogen atoms, chlorine, bromine, and these halogens in the atmosphere break down the ozone, and they create a positive feedback loop where one chlorine atom or one bromine atom can wreck or cause ozone to not be formed over and over and over again. So these can be, the CFCs were used for a lot of different things. Their manufacture is now either banned or it is severely limited depending upon your country's economic status. We used them everything from spray can propellants, like, in aerosol sprays like room deodorizer and hairspray. The HFCs were developed to replace the CFCs. Unfortunately, we found that not only do they destroy the ozone layer by releasing chlorine atoms, but they also are a stronger greenhouse gas than the original CFCs were. Halons, these are very interesting because they're used in all sorts of industrial fire suppression systems, like in large buildings, airports, things like that. Methyl bromide is a pesticide, and nitrogen oxides are used in intensive farming to break down the nitrates and the nitrates in soil, and you also find them in the contrails of the high-flying jet aircraft, and all of them in some way interfere with the manufacture of ozone, or it breaks down the ozone layer. So let's talk a little bit about ODSs. The CFCs, which were the earliest ODS, they were developed in the 1930s, and they were considered a miracle chemical. They were the answer to a lot of technical problems when it came to refrigerants. Previously used refrigerants were reactive and toxic. They were difficult to handle, and this was a huge problem. ODSs, when they were developed, they were non-reactive, so they weren't flammable. They were inert, not toxic, at ground level. It took over 40 years to figure out that the CFCs were reacting in the stratosphere. So in the 1970s, when this research came out about the ozone layer, scientists were very quick to outline what the mechanism is, that with UV radiation, how the chlorine atoms released by the CFCs reacted with ozone to destroy the ozone layer, and also the chlorine atoms reacted with oxygen to prevent ozone from forming. And so this vicious positive feedback loop really allowed huge destruction of the ozone layer. So what to do about this problem? Well, first of all, scientists needed to understand the ozone cycle, which is shown here. where not only are oxygen atoms broken down to, oxygen molecules are broken down to oxygen atoms so that ozone can be formed, but you've also are showing here on this the reaction where you have oxygen molecules, O2, are in dynamic equilibrium with the formation of ozone. So initially, it was really easy to find chemicals that were very effective to replace HFCs for aerosol cans and blowing agents for plastics. You have to understand that plastics are molded by injection molding, which means that gas is blown into a plastic so that it will mold to a particular shape. And it was easy to find HFCs to fill this purpose. But finding good refrigerants, effective refrigerants, was a much harder deal. They really couldn't go back to what they were using before for refrigerants because, as I said, they are toxic and they were hard to work with and they were flammable. So you ended up having HCFCs developed, but then they figured out that HCFCs also destroyed the ozone layer, contributed to the greenhouse effect, and while the HCFCs stayed in the atmosphere a whole lot shorter time than the CFCs, the greenhouse effect that they produced was stronger than CFCs. So because CFCs are really, really super stable, they last in the atmosphere for a really long time. They speculate up to 100 years after their release. That's what scientists think. So as a result of that, a thicker ozone layer is going to take a long time to regenerate. So that's one of the reasons why a lot of different countries came together under the auspices of the United Nations. And in 1987, they signed the Montreal Protocol, which is to phase out the production of ODSs. What's interesting about this is all 197 countries that were recognized on Earth at the time all ratified this treaty. So everybody is participating. Main points of this treaty was to freeze the consumption and production of ODSs to levels before the protocol was signed by the year 1980. And there was mixed results with that. And to strongly reduce the consumption and production of ODSs by the year 2000. It's been strengthened because there were some weaknesses in that initial agreement 7 different times. Some of them are topic specific and some of them are more general, but they've been strengthened 7 times with additional amendments, including the most recent, which is the Kigali Agreement. This is also an agreement that recognizes that there's differences between LEDCs and MEDCs. Because the developing countries have less resources, they are given a longer time to implement the treaty. The Montreal Protocols will be implemented in a shorter period of time by the developed world because they have the resources to be able to do that kind of implementation right away, and they have more resources, scientific and industrial, in order for that to be happening. So what's the significance of the Montreal Protocol? Well, the significance is that this is the first environmental agreement that is truly a global agreement. All the countries on Earth, as I said, in 1987 that were recognized, all signed on to the Montreal Protocol, and this was all negotiated through the auspices of the United Nations Environmental Program. Another important significant point was that this is an example of experts from a lot of fields, not just scientific fields, but political and government and industrial fields. They all came together to figure out what the problem was, research, and come up with solutions. And all of the decision making was based on good science. This is also the first environmental agreement that allows implementation by economic status. Previously, when environmental agreements came out, it was very, very hard for the developing world to comply, and oftentimes they didn't sign on to them because they don't have the resources that the developed world has, and so they knew that they couldn't follow through, so they didn't sign on. This agreement allows for the developing world to proceed at a slower pace, and it also allows for the developed world to put money into a fund to help the developing world. This agreement also has a monitoring clause. Not a lot of previous agreements had a monitoring clause. Other agreements in the past, they were really good moments on television where, people from countries could look really good and be saying, yes, I'm supporting the environment, and then go home and do absolutely nothing. Because there was no way for these agreements to be monitored and policed. This one is different. So the countries who have signed on to this, they are giving up the ability to hide their inaction. They have to participate. So what does this mean for the future? CFCs have a long time life in the atmosphere, and chlorine gas in the atmosphere did not reach its peak levels until 2005. Luckily, it's been going down since then. But we're not going to be reaching 1930s era, which is before pre-ODS's levels before 2050. So it's going to be not in my lifetime, but perhaps in your lifetime, that we will have a fully regenerated ozone layer. But because CFCs are cheap to make and they're very effective, there's a really, really strong black market, particularly in the developing world, for CFCs. And so the monitoring must continue in order to stamp out this black market. I hope that you've enjoyed part 1 and part 2 of topic 6.2 lecture. Thank you very much.